Ever wondered what technology stack powers your favorite mobile apps? The term might sound complex, but it's simply a combination of software tools and programming languages that work together to create a digital product. In our case, a mobile application. A technology stack consists of four key components: the front end, which is what you interact with on your device; the back end, responsible for server-side operations; the database, storing and organizing all the data; and lastly, the development platform, where all the magic happens. In the world of mobile app development, choosing the right technology stack is crucial. It's like selecting the right ingredients for a recipe. The right combination can lead to a smooth, user-friendly app, while the wrong one can result in a less than stellar user experience. So now that we understand the basics, let's delve into the specifics of Android, iOS, and hybrid app development stacks. Diving into the world of Android, what does its technology stack look like? It's a fascinating realm, teeming with a variety of tools, languages, and frameworks that enable the development of diverse and innovative apps. Let's start with the programming languages. Java has been the trusted cornerstone of Android development since the platform's inception. Its object-oriented approach and vast open-source ecosystem make it a reliable choice for many developers. However, in recent years, Kotlin has emerged as a more modern, streamlined alternative to Java. It's fully interoperable with Java, yet it offers a more succinct syntax and a host of modern features. Google has officially declared Kotlin a first-class language for Android development, so it's certainly worth your attention. Moving on to software development kits or SDKs, the Android SDK is a crucial part of the stack. It provides the libraries and APIs necessary to interface with the underlying Android platform. It also includes a range of debugging and testing tools to help ensure your app runs smoothly. When it comes to development tools, Android Studio stands head and shoulders above the rest. This official IDE for Android development is packed with features, from code editing, debugging, and testing tools, to built-in support for Google Cloud Platform. Eclipse was once a popular choice, but since the advent of Android Studio, its usage has dwindled. Next, let's touch on the Android-specific libraries and frameworks. Libraries like Retrofit, for handling HTTP requests, or Glide and Picasso for image loading, are immensely helpful. Frameworks like Dagger or Hilt for dependency injection can significantly enhance the structure and scalability of your code. Lastly, databases. Sklite is a lightweight, file-based database that's baked into the Android platform, making it an obvious choice for many apps. However, Realm is another popular option, offering a more object-oriented approach and a richer feature set. With a solid foundation in Java or Kotlin and the right set of tools, you're well on your way to developing Android apps. So keep exploring, keep learning, and most importantly, keep creating. Now let's switch gears and talk about the tech stack that powers iOS applications. When it comes to iOS app development, two primary languages lead the charge: Swift and Objective-C. Swift, the more recent of the two, is a powerful language designed for safety, speed, and efficiency. It's expressive, easy to read and write, making it a favorite among many developers. On the other hand, Objective-C, the elder statesman of the two, is a superset of the C language. It's robust, dynamic, and provides a solid foundation for writing software. While Swift is gaining popularity, Objective-C still holds its own, especially in maintaining legacy code bases. Next up in the iOS tech stack is Xcode, Apple's very own integrated development environment, or IDE. Xcode is the cockpit from where developers control the creation of iOS apps. It offers a suite of tools that streamline the development process, including a powerful editor, a robust debugger, and a comprehensive set of performance analysis tools. It even includes Interface Builder, a graphical editor for designing user interface components. Now onto the iOS SDK, the software development kit. This is the foundation upon which all iOS apps are built. It provides a collection of libraries and tools that developers use to create, test, and debug apps for Apple's mobile platform. The iOS SDK works hand in hand with Xcode, providing the building blocks developers need to create compelling iOS applications. Speaking of building blocks, let's not forget the frameworks. UIKit, for instance, provides a set of user interface components for building graphical, event-driven applications. It's like the paint and brushes for your app's canvas. Core Data, another popular framework, simplifies data management tasks, making it easier to persist data across app launches. Last but not least, we have databases. Core Data, as we've mentioned, serves as an object graph and persistence framework, while Realm is an open-source database platform specifically designed for mobile applications. These databases help manage and store app data efficiently. Armed with a strong command of Swift or Objective-C and a good grasp on Xcode, you're ready to conquer the iOS app development world. But what if you want the best of both worlds? Enter hybrid app development. Hybrid apps are a blend, just like their name suggests. They are web applications built with HTML, CSS, and JavaScript, but they live inside a native app shell. This shell can access platform-specific features, giving them the look and feel of a native app. Their biggest selling point is their cross-platform compatibility. Write once, run anywhere, that's the motto. But what powers these hybrid apps? What's in their technology stack? Let's dig in. At the heart of any hybrid app are frameworks. These are the tools that allow developers to write code once and deploy it on multiple platforms. Some of the most popular frameworks are React Native, Flutter, and Ionic. React Native, created by Facebook, uses JavaScript and allows developers to build mobile apps using the same design as a React, which enhances the user interface. Then we have Flutter. Flutter, developed by Google, uses Dart language. It's known for its fast development, expressive and flexible UI, and great performance. Ionic, on the other hand, is an open-source framework that uses web technologies like HTML, CSS, and JavaScript. It's known for its rich library of pre-designed components, gestures, and tools. Each framework has its own strengths, and the choice often depends on the project requirements and the team's expertise. What about the tools? Well, the most common ones are Visual Studio Code, Android Studio, and Xcode. Visual Studio Code is a lightweight but powerful source code editor that runs on your desktop. Android Studio and Xcode are the official IDEs for Android and iOS development, respectively. They provide advanced coding, debugging, and testing tools. And let's not forget the languages. JavaScript and Dart are commonly used in hybrid app development. JavaScript is the staple of web development, and Dart, though less popular, is praised for its simplicity and performance. So, with hybrid app development, you can use a single codebase to target multiple platforms. Quite efficient, isn't it? Now, let's not forget about the unsung heroes of our app, middleware and databases. In the world of mobile app development, middleware is the unseen glue that holds everything together. It's a layer of software that connects disparate systems, enabling them to communicate and share data. Middleware is like a translator, making sure that all the different parts of an app can understand each other. From the front-end interface that users interact with, to the back-end servers where data is stored. Popular middleware options abound, but let's focus on a couple of standouts. Node.js, for instance, is a real favorite among developers. It's built on Chrome's V8 JavaScript engine, known for its high performance. Node.js is perfect for building scalable network applications, making it a great fit for mobile app development. Express.js is another compelling choice. It's a minimalist web application framework for Node.js designed for building web applications and APIs. Express.js is fast, unopinionated, and flexible, allowing developers to choose their own adventure when it comes to building their apps. But what's a mobile app without a place to store and manage data? That's where databases come in. Databases are the treasure troves of apps, housing all the valuable information that makes an app useful and engaging. SQLite is a popular database for mobile apps, known for its small footprint and full feature set. It's an in-process library that implements a self-contained, serverless, zero-configuration, transactional SQL database engine. This makes it a solid choice for apps that need to manage a moderate amount of data without the overhead of a server-based solution. MySQL and MongoDB are also widely used. MySQL is a full-featured relational database management system, while MongoDB is a source-available cross-platform document-oriented database program. Both offer robust solutions for managing and organizing data in mobile apps. Remember, an app isn't just what you see on the screen. The middleware and database hold everything together behind the scenes. Let's quickly recap what we've learned today. We dove into the intricate world of mobile app development, starting with the Android app development stack. We've seen how Kotlin and Java are key languages, along with tools like Android Studio and Android SDK. Then, we moved on to the iOS app development stack, focusing on Swift and Objective-C as the central languages, not forgetting Xcode, the primary development environment. Next, we delved into the realm of hybrid app development stacks, highlighting the versatility of frameworks like React Native and Flutter, which allow for cross-platform development. The critical role of middleware and databases was our next stop. We've seen how they facilitate communication and data management with SQL and NoSQL databases, and middleware technologies like Node.js. With a clear understanding of these technology stacks, you're well equipped to make informed decisions in your next mobile app development project. Until next time, keep exploring and keep learning.